Hello and welcome. In this video, I want to show you how to use the method of the section to calculate the forces in a truss like that. And the benefit of using this method is you can target it, specific members without having to solve every single member in the truss. It's very useful method to save time. So let's say in this example, we want to figure out the force in member CD and in member CJ and in member KJ. There's actually a way to do this without solving every single force or every single joint. So if you use method of the joints, you will have to move from one joint to another. If you use the method of the sections, you can just like target specific members. The only thing about this method is you need to pick a section that completely separate the truss into two separate parts. Let's call it the right hand side and the left hand side. But you need to pick a section, hence the name section, method of the sections, that pass through maximum 3 members. Because if you pick, for example, a section like this that pass through 1, 2, 3, 4, 4 members will reveal 4 internal forces, which is too much. We only have 3 equilibrium equations. So I need you to pick a section that goes through maximum 3 members. So since we already want to know CD, CJ, and KJ, I will pick a section that separates the truss at this point here. I will do a dotted line and use this section. And this section is going to reveal the internal force here in CD, in CJ, and in KJ. So what you need to do is completely isolate the truss into two separate sections. So I will call this the left hand side. I will do my dotted line. I will include everything from the left, and everything inside my dotted line is in equilibrium. So that's how we're going to figure out the forces. Everything outside of it is in equilibrium as well. That's why you can solve this problem from the right hand side or from the left hand side. Okay, step number 1, if you look closely, you will realize that I have a support inside the dotted line. So step number 1, I'm going to need to calculate the reactions. Any guess what type of support this is? Well, obviously this is a hinge support and this is a roller support. So if we are looking at a roller support here, this will give us Gy, one reaction at G, and at AX I will put a reaction at A, I will call it a Y, and a reaction in the X direction I will call it a X. The reason I started with this is I need to know the unknown reactions in order to analyze this section, the left hand side section. So in order to do that, I will study the overall equilibrium of the truss. This is a step that we're pretty familiar with right now. So for the entire truss, I will consider the summation of forces in the x direction has to equal 0, and automatically you will realize the only force in x is AX, and therefore AX equal 0. So there is no AX. This guy is pretty much 0. The second equation, I'm going to take the moments about A, the summation of moments about A has to equal 0. So this will result in a very interesting equation. What are the forces that are rotating about A? I have Gy. What's the distance between Gy and A? Well, I have 1, 2, 3, 4, 5, 6. I have 6 base times 4 meters, so this is 24 meters. This is meters. And is this going clockwise or counterclockwise? Is this force rotating about A clockwise or counterclockwise? Well, it's going counterclockwise, so I'll take that as a positive. Next is the 10 kilonewton. So the 10 kilonewton is going clockwise, which is against Gy. So I'm going to take it as negative 10 kilonewtons. The distance here is 1, 2, 3, 4. It's basically 4 times 4, which is 16 meters. I counted for this. Now this 10 is 8 meters and it's also going clockwise, so minus 10 times 8 meters. And the last but not least, another 10 meters multiplied by 4. And if you look closely, the only forces that will cause rotation is like 1, 2, 3, 4, and I counted 1, 2, 3, 4, so I should be okay. If you add all of this up, it should equal 0. The only unknown here is Gy. So I will very quickly use my calculator. I'll do the math here. 10 times 16. I'm going to add to it 10 times 8 times 4. And when I move all this to the opposite side, it will become positive divided by 24. I will get Gy to be positive 11.667 kilonewton. So the positive sign means that this force is actually going up. I will apply the, this is the first equation, the second equation. Any guess what's the third equilibrium equation is? Well, you probably guessed it right. It's the summation of forces in Y has to equal 0. What are the forces going up? AY is going up. GY is going up as well. So I'm going to add it. And we know it's 11.667 kilonewtons. Minus everything going down, which is 3 forces times 10 kilonewtons. So it's going downward 30 kilonewton. And when you add all of this up, it has to equal 0. This pretty much will give us AY will equal, if I do the 30 minus 11.67, pretty much this is 18.333 kilonewton. So this force is positive and it's 18.333 kilonewton. So what do we do from here? I need to draw the free body diagram of everything inside the dotted line. So any guess what will happen here? We will reveal the internal force and I will assume its attention away from the side I'm considering. So I will take this free body diagram of the left hand side. I will put the horizontal line, the top, this is joint C, This is joint K. I have L and B, and I have A as well. And you can put CK. That's not gonna harm us. I want you to notice where your section is. So because you interrupted CD, you need to replace CD with a force. I need to assume this force as tension. So in order to use the tension is positive rule, so I will take this force as CD. I also need to replace this member with a force, CJ, and it's going in the direction CJ. And if you follow the dotted line, you will see that you intersect with KJ. So KJ needs to get a force as well. Okay, so if you follow the dotted line, you will see the reactions are inside. So I will put, this is just 0. There is an upward force here that is 18.333 kilonewton. All right, so this is detaching the left side of the truss. I considered internal forces and I considered the reactions. Is there anything missing? What about the external loads? Well, the external loads, they have to show up as well. So I need to put a 10 kilonewton here and a 10 kilonewton here as well. Okay, so what's the magic about this diagram? The magic is this diagram is in equilibrium. So the summation of all the forces in X has to equal 0. The summation of all the forces in Y has to equal 0. The summation of moments about any point has to equal 0 as well. Okay, so now it's time to get some dimensions and some angles, because you probably guessed it right that these forces will have to get X and Y components. So if I put a horizontal line here, any guess what this angle is? Let's call it theta. Well, it's the same angle of this top chord. This top member has an angle theta as well. So how do we get the angle theta? Well, if we know this height, dj, which is 6 meters, and we know the bottom, aj, which is 4 times 3, we can get the angle. So I will do the quick math here. This is triangle A, D, J. It's a right angle triangle. This is 6 meter, 4 3 times, this is pretty much 12. And now how do we get theta? I like to consider that tan theta equals the opposite divided by the adjacent equals 6 divided by 12. And this will result in theta that is going to be inverse tan 6 divided by 12. And if I get inverse tan, the answer, it's about 26.565 degrees. If you use this method, I suggest that you keep the 3 decimal points for accuracy, and this automatically will result in cosine theta and sine theta. I will just store this number, and we'll get cosine this number. I will take 3 decimal points, 8, 9, 4, and I will do the sine this number. This will get us 0.447. You can do the trigonometry thing and calculate this side. That will be 6 squared plus 12 squared. If you get the square root of this answer, that means this is 13.416 meters. Cosine is the adjacent divided by the diagonal. 12 divided by answer. That's the same number, pretty much, the 894. So this angle is the angle between C, D, and the horizontal. If I put a horizontal line here, this is theta. All right. Is that it? Is this everything we need to know about the angles? We need this angle as well. So how do we get it? How do we get this angle? So there are a few ways to do that. Is it possible to calculate this angle, or maybe it's possible or easier to get this angle? So I will call this angle beta. And now we'll try to figure it out. What's the height of this member CK? So CK, similar to this triangle, I can pretty much say that CK divided by DJ by similar triangles will equal AK divided by AJ. And luckily, we know that AK is 8. We know AJ is 12. And we happen to know DJ as well. So DJ is 6. All of this will give us CK to be 6 times 8 divided by 12, 4 meters. So this is 4 meters. Okay, what's the benefit of knowing this? Well, look at this. This is 4 meters. This is 4 meters. And this is 90 degrees. Any guess what those are? Well, you probably guessed it. This is 45 degrees, and beta is 45 degrees as well. So the angle between the vertical and CJ is beta, which is 45 degrees. And since this is 45, this is 45 as well. So now I'm going to do what we always do with a force with an angle. I'm going to get the x component, which is going to be CD cosine theta, and the vertical component CD sine theta. For CJ, I'm going to get the horizontal component, which is going to be CJ sine beta, which is interesting because beta is with the vertical, and I will get this component to be Cj cosine beta. And now I'm ready to apply some equations. There is a smart way to do this, and there is the hard way to do this. For example, if you started by taking the summation of moments about point A, for example, you'll have a whole bunch of unknowns. You'll get the vertical components of these two forces as unknowns and the horizontal components times distances, and it's going to be it's going to take a lot of time, and it's not going to give you a lot of unknowns right away. One thing I like to do is take the summation of moments about the point with the most number of unknowns. So for the left hand side of the truss, I'm going to take the moments about the point with the most number of unknowns. Any guess which point has the most number of unknowns? To me, it looks like C. So I'm going to take the summation of moments about C and equate that to 0. The summation of moments about C has to equal 0. So what are the forces that are causing rotation about C? Does any of the forces acting at C cause rotation about C? The answer is no. If the force passed through the joint, it doesn't cause rotation about it. So I'm going to start with the force Kj. If you put your finger at C, you will realize that this is rotating counterclockwise, and counterclockwise I normally consider it as positive. So Kj, that's the force multiplied by the distance. What is the perpendicular distance from Kj to C? Well, you put your finger at the point of rotation, you extend the force, and then go from point of rotation perpendicular to the line of action of the force. So you will realize that this distance, CK, which is 4 meters, is the perpendicular distance. And it's going counterclockwise, so it's positive. Is there any other force causing rotation about C? How about this 10? So is it going clockwise or counterclockwise? Well, it goes in the same direction as Kj, counterclockwise, so I'm going to consider it as positive. 10 kilonewton multiplied by the perpendicular distance. I'm rotating about C. Put your finger at C, extend the force, go from point of rotation perpendicular to the line of action of the force. You will realize that this distance is 4. So I will do the 4 meter. This will leave us with just one force, and it's rotating the opposite direction, clockwise, so I'm going to consider it negative. The magnitude is 18.333, and the distance is from C. I'm going to extend the force and go perpendicular to the force. This distance is 8 meters. And this is the force in kilonewtons. Is there any other forces causing rotation about C? 1, 2, 3. 1, 2, 3. That's everything. What happens if I add up all these moments? The answer should equal 0. That's what this equation means. The summation of moments about C equals 0. So I will do quickly the math. 10 times 4 minus 18.333 times 8. This will go in the opposite side and divided by 4. If you look at the numbers, this will result in Kj equals positive 26.666 kilonewton. In this case, the positive means this assumption is correct. This assumption is tension, so this force is tension. I will go very quickly and put the direction of tension here. It's going away from K, and it's going away from J as well. So by now we know that the forces at the ends of each truss member are equal and opposite. So if it's tension away from this joint, joint K, it's also tension away from the opposite joint J. All right, now we need to figure out the other forces. I can go ahead and take the summation of forces in X equals 0. The summation of forces in X has to equal 0. I will realize that the only forces in X are C, D, cosine theta, positive X, plus C, J, sine beta, positive X as well, plus KJ, which happens to be 26.666 kilonewton. When I add all the three, it has to equal 0. So I have two unknowns here. To help me out, I will do the third equation. If this is the first equilibrium equation, that's the second equilibrium equation. The third equilibrium equation is the summation of forces in Y has to equal 0. So anything going up, including the reaction on the entire free body diagram, minus everything going down, will have to equal 0. So in this case, 18.333 kilonewton going positive Y plus C D sine theta going positive Y minus CJ cosine beta minus any other force, any other external force on the diagram as well. So I have two 10 kilonewtons going downward, so I will subtract 10, subtract 10. This is kilonewton, and this is kilonewton. Did I miss anything? Did you account for everything? So I counted for the reaction, for CD going up, CJ going down, and two forces going down. When you add all of this, the rule says it should equal 0, so I'm going to equate it to 0. Okay, this is another equation in two unknowns. So how do I solve it? I'm going to choose to solve for CD. So I want to get a function of CD as a function of CJ. So this basically will equal something like that. 26 will go negative on the opposite side, minus CJ. I know that beta is 45, and therefore sine 45, which is equal sine 45 equals cosine 45. I will put it as 0.707. All of this will have to be divided by cosine theta. Do we know how much is cosine theta? Well, we happen to figure it out early on as 0.894. This will enable us to replace this with this number. So you can do the math and figure out how much is CD. When you crunch the number, you will see that Cj will pretty much equal negative 14.136 kilonewton. The negative means that it turned out to be compression. And when you do the substitution again for Cj here, you can get Cd. You crunch the numbers, you will realize it's also negative 18.647. I like to keep the 3 decimal points for accuracy. Kilonewton. This is also compression. So very quickly, if I could show you the direction of compression on joint C, Cj is compression, so it's going into the joint, and this is correct for joint J as well, so the compression is going into the joint. CD is compression as well, so CD is going into the joint, and it's correct for the opposite side. So this is pretty much the forces we are looking for: CJ, CD, and we also got KJ. I want also to mention that as an exercise, you can take the right hand side and you satisfy the same 3 equations, moments and force in X and Y. You will see that this side is in equilibrium as well. So you can solve it from the right hand side or from the left hand side. That's pretty much it, and I will see you in another video. See ya.